Hey guys, Mrs. Millsap here. In this video, we are going to talk about the periodic table, the groups and families that make up the periodic table, and how it really came to be. The periodic table is arguably one of the most important documents ever made, really. And I'll hopefully defend that statement here in just a second. The periodic table is an insanely organized system of 118 elements, but we didn't used to have 118 elements. So who first came up with the very first periodic table? Well, we don't really have an answer for it, but I do have an answer for the first person who we credit with coming up with the periodic table, and that is Dmitry Mendeleev. Dmitry was a Russian school teacher, and he, along with lots of other people, tried to find a way to organize the elements that they knew existed in the known universe. So he tried to organize the elements for his students. In doing so, his method, the reason why his method is now known and why he's credited for the first periodic table is because his periodic table was organized in two ways. The first way it was organized is through the mass of each element that was known and the properties of each element. And in doing so, he accounted for elements that had not existed yet. Later on, of course, we know what elements fill these gaps and holes. And we've come up with what we now know as the modern periodic table. Before we get too excited and just jump right into that, I wanted to review some key vocabulary terms before we got too into it. And so the first is, what is a period? Periods are the number of energy levels, and the energy levels of an atom will increase as you go down the periodic table. From top to bottom, we see the periods increase. So we start at 1, we work our way all the way down to 7. Those are the periods. Okay. The groups represent the number of valence electrons. Now, not all group numbers represent valence electrons. Remember, we've learned that groups 1, 2, and 13 through 18 represent valence electrons. And then there's a group in the middle from 3 to 12, this middle, the D block. And those group numbers, don't actually represent valence electrons because the valence electrons of the D block changes. So there's not only one valence electron. There's not one known number of valence electrons for this group. But the number of valence electrons will increase as you go from left to right on the periodic table. Okay. The word family we're going to learn more about here in a second, but family just stands for a specific group. Okay, so everything in group 1 is considered a family. Everything in group 2 is considered a family. And part of that is due to their valence electrons. Everything in group 1 has one valence electron, so they tend to react in similar ways, and so we say they're all part of the same family because they're all similar. Okay, valence electrons are the outer electrons inside of an atom. And we know the valence electrons of elements in group 1, 2, 13 through 18 by their group number. Electron configuration is when we draw out the location of all the electrons inside of an element by using our 1s2, 2s2, 2p6, and so forth system. Okay. So now let's go ahead and move on to talking about the modern periodic table.